All right, today we're looking at lesson 2.1, starting chapter 2. And it's going to start to feel more like, I think, what you thought algebra was going to look like, where we're going to start combining like terms. Today we're going to use the distributive property, moving towards solving equations, all stuff that you were kind of prepped for in Math 7 and Math 8. So today, again, we're going to look at the distributive property. So the big idea today says by applying the distributive property, you can rewrite the product A times the quantity B plus C as the sum of A times B plus A times C. So it's saying that these two are equivalent to each other. So we can break that down into two kind of separate properties. So the first one being the distributive property of multiplication over addition. And you'll find this in the textbook. It'll say for all real numbers A, B, and C, meaning for any number, fraction, decimals, positive, negative, it holds true that C times A plus B can be rewritten as, and we always kind of used to draw those little lines that connected. So you say C times A, C times B. So when we distribute, it's C times A plus C times B. So when you have a number being multiplied times a quantity, two things being added together, you can rewrite it as the product of the outside number times both of these inside numbers and then add it. So it's kind of just changing the order that you do things. But if we plug numbers in here, this will hold true that they're equivalent and they're equal to each other. So the distributive property of multiplication over subtraction is going to look very similar. So if we have C times the quantity A minus B, think about what this is going to look like. So we're still going to multiply C times A and C times B separately, and now they're just going to be separated with a subtraction sign. And again, if we plug numbers in here, this will hold true and be equivalent. So example number 1. This looks very basic, something you may have seen in even 6th grade, 7th grade for sure. So using the distributive property to simplify. So we're going to simplify this. We're going to get rid of the parentheses. You can draw the little loops if it helps you. Whatever number's on the outside being multiplied times the quantity, you can multiply it times each individual term, and we'll form an equivalent expression. So 5 times m is 5m. We see this is plus. Now, I don't want you to automatically put plus just because we see that. I want you to think about it's a positive 5 times a positive 4. So we have a positive answer. So since that's a positive 20, I write plus 20. But if I would have got a negative 20, I'd write it as minus 20. Technically, it's plus negative 20, but in chapter 1, we discussed plus negative 20 is the same as minus 20. And we want this to be simple, so that's what we'll look at. Now, we're going to multiply here, and some of this is going to be kind of new. We haven't multiplied a variable times a variable that much, so we want to go over that. So we're going to do 10b times 2b, and then 10b times c. So what happens? So when you multiply these two, the coefficients just get multiplied. So 10 times 2 is 20. But b times b is not just another b. Okay, that when you multiply two variables, what happens is the exponents get added. Each one of these b's has an exponent of 1. It's just not written. So b to the first times b to the first is b to the second. So 10b times 2b is 20b to the second power. Plus, multiply coefficient of 10 times a coefficient of 1, which isn't written, but there's a 1 there. So that's going to be a 10. And when you're multiplying different letters, you're just going to combine them and just write them as multiplication because we can't actually do anything with them right now. So it's going to become 10bc, which still says 10 times b times c. So we multiplied them, and we're still multiplying them here. We haven't done anything with them. And this is it. It's our final answer. So what happens if I have a trinomial, 3 numbers being added together in here? Well, all 3 get multiplied by that number on the outside. So multiply here, 6x, multiply here, that's 8, and multiply here, and that is 16y. So if you multiply a number times another term that has a variable, the variable just kind of tags along. All right, let's look at some now that may be a little trick here. Multiplying here, we've got some just new looking letters. We've got subtraction in there as well. So when I multiply here, It's just going to be a 2 because it's 2 times 1. And since they're different letters, I have to leave them as a product. And so this is going to be one term, but it's just one big product, 2 times G times D. So basically, you're just going to combine the letters together when you multiply different variables. So when I multiply this, it's a positive 2. You can think of this like a negative 1. So it's going to be a negative 2. So I write it as minus 2. And the letters are different, so I'm just going to combine them. So it's a G and an E. So 2 times GD minus 2 times GE. All right, now we're going to throw a bunch of negatives in there. Multiplying here, negative times a negative is a positive 21. And now we're going to treat this like a negative 2. So it's negative 7 times negative 2, which is a positive. So I'm going to write plus. So this was the situation I was referring to. Don't just see subtraction and bring it down. You got to look at what you're multiplying. If it's a negative times another negative, we're going to be a positive and we write plus. 7 times 2 is 14, and the x tags along. Now, when you had me in 7th grade, you definitely would rearrange this. So we can rewrite this as 14x plus 21. And you may or may not see that in the answer key rewritten, but you don't have to. Now, this is proper, okay, and a lot of time you will see it rearranged where the variable goes up front. If there's more than one variable, they'll be in alphabetical order. But this is a perfectly acceptable answer. 21 plus 14x is just fine. Over here, let's multiply. A negative times positive is a negative 55. And then a negative times a negative, that's a positive. So I write plus 66W. This answer is perfectly fine. Now, if I was going to switch this, okay, the whole thing moves. The positive 66 moves. I don't leave this negative out front. And when I bring the 55 to the end now, that's negative sign acts like a subtraction sign. So rewritten, it's going to look like this. All right, that should be kind of a review. I know I taught you that in 7th grade. You probably saw a lot more of it in 8th grade. But let's start looking at some fractions. Simplifying a fraction. So when we have an expression, like an addition or subtraction expression, on top of a single denominator, we can actually split these into 2 separate fractions. So it's part of the distributive property because it's kind of like we're dividing each one of these individually, just like up here we're multiplying each one of these individually. So what I can do is kind of break this into 2 separate fractions, and they say the same thing. So I can take the 36 over 18, and I can put the 3x over 18. And these 2 things say the same thing. Now, what I can do now is I can simplify each individually. Where up here, there wasn't really anything I could do. All right, right now I can simplify. 36 divided by 18 is 2. And if you look at the 3 over 18, forget the x for a second. 3 over 18 as a fraction would simplify down to 1/6. So you could write 1/6, and the x would tag along. And now you're never going to see a 1 written like that. So really, in the end, this is going to look like 2 plus x over 6. That's what you're going to see. They may even put the x up front, but that 1 is not going to be in front of the x. So if we come over here, split this into 2 separate fractions, 24 over 8. If this said minus, I'd put minus, but it's plus 6x over 8. So 24 divided by 8 is 3. And then again, imagine the x isn't there. 6/8 reduced to 3/4. And so you're actually going to leave it like this. It's 3/4 x. Technically, you could write it like this with the x separated and not in the numerator. And these say the same thing. And you could even turn 3/4 to a decimal. We know that's a very common fraction. 3/4 is 0.75x. So any of these are fine. You can leave x up in the numerator. You can take x out and just have a fraction times that. Or you can even turn it to a decimal. And they all mean the exact same thing. All right, so last one, we got a little bit of subtraction going on here. So when we separate these, 30 over 10, we're just going to use subtraction. 2x over 10. So 30 over 10 is 3, and 2/10 would reduce down to 1/5. So instead of putting the 1, I'm just going to put the x over 5. Now, if you were going to rewrite it with the fraction in front, it would look like 1/5 x. And 1/5 is 0.2, so you could even write it as 0.2 times x. All of these say the same thing. All of these would be acceptable answers.